Welcome to my channel Cherish Physics. Subscribe my channel and keep watching. In my channel, I have uploaded important MCQs in all the units of UG TRB exam. It's in my playlist, so make use of it. Now let us see the important points in Unit 3, Properties of Matter and Acoustics. Here is Unit 3 syllabus. Go through it. And today we are going to see the topics elasticity, moduli of elasticity, and the relation between three moduli of elasticity. In elasticity, Newton's law comes into play. By Newton's second law of motion, we know force equal to mass into acceleration. That is, if we apply a force on an object of mass m, it accelerates if the object is in a free state. If suppose the object is not able to move, it gets deformed. See it in the picture. The circular object becomes an oval shape when the force F is applied. Now, according to Newton's third law, each atoms or molecules changes in position and each of it acquires a force. That force is called internal force. When the external force F is removed, this internal force brings the object to regain its original dimension, that is, size and shape. Most of the materials are classified according to its elastic and plastic nature. The body which regains its original dimension after the deforming force, that is external force, is removed is called elastic body, and this property is called as elasticity. On the other hand, the body which do not have the tendency to regain its original shape after the external force is removed is called plastic body, and this property is called as plasticity. In the picture I have written steel is more elastic than rubber. If you know the reason, write your answer in the comment box. Next, let us see stress and strain. By simple words, we can say if you apply a force on the object, we are stressing the object. Due to this stress, the object gets strained. But in physics, we have to study it in detail. Stress is defined as the restoring force per unit area. Stress equal to restoring force divided by area. The SI unit of stress is Newton per meter squared or Pascal, and its dimensional formula is mL-1T-2. Moreover, stress is a tensor quantity, specifically a second order tensor. I have discussed only the important points because for the exam point of view. Next, strain. When a deforming force is applied, there is a change in length, shape and volume of the body. Therefore, strain is equal to change in any dimension divided by original dimension. Strain has no unit since it is the ratio between two similar quantities. It is a dimensionless quantity, and strain is also a second rank symmetric tensor. Stress is classified into longitudinal stress, shearing stress and volume stress. First, let us see longitudinal stress. From the term longitudinal, it is understood that the force will apply on the object lengthwise. So the object will experience elongation or compression depends on the direction of the external force. See the picture. I have drawn a rod-shaped object and a force F is applied on the object. First, let us consider a small cross-sectional area delta A, and the applied force F is resolved into two components perpendicular to each other, normal force Fn and tangential force Ft. Longitudinal stress is the normal stress over the area delta A is equal to Fn, the normal force, divided by delta A. The force on the object acting outwards, the object gets stretched or elongated. So the stress on the object is said to be tensile stress. If the force is acting inwards on the two sides of the object experiences compression. The stress on the object is said to be compressive stress. Next, the tangential stress or shearing stress over the small area of cross section delta A is equal to tangential force Ft divided by delta A. Third one, volume stress. The force applied on the object in all the direction, it experiences volume stress. Volume stress equal to force by area. If stress is classified as longitudinal stress, shearing stress and volume stress, then strain is also classified into longitudinal strain, shearing strain and volume strain. Longitudinal strain is equal to change in the length of the rod divided by original length of the rod, which is equal to delta L, change in length of the rod, divided by L, the original length of the rod. If the length of the rod increased from its original length, the object undergoes tensile strain. If the length is decreased from its original length or natural length, then it is called as compressive strain. Second one is shearing strain. For this, let us consider a cube, and the cube is fixed at the bottom. Here, the force is applied on the top layer of the cube, that is, the force acting parallel is said to be tangential force. See the picture. The force on the cube makes it to move through an angle theta. It transforms into parallelogram without changing the volume. Shear means a movement through an angle. Hence, shearing strain, which is equal to angle of shear theta. Third one, volume strain. In volume stress picture, we have seen a sphere and forces applied on all the directions. So, the object gets strained. Its change in volume is delta V and original volume is V. Therefore, volume strain equal to delta V by V. Next, let us see some important terms. The first one is elastic limit. The maximum stress within which the body regains its original size and shape after the removal of deforming force is called elastic limit. After this limit, the body gets deformed even though the force is removed. Next, yield stress. The stress at which the material transforms from elastic to plastic. Next is the very important law, Hooke's law. Hooke's law states that within the elastic limit, stress is directly proportional to strain. That is, stress divided by strain, which is a constant, and the constant is called as modulus of elasticity. The dimensional formula of modulus of elasticity is m L minus 1 T minus 2. Its unit is n m to the power minus 2 or Pascal. Now let us see the moduli of elasticity. It is of three types: Young's modulus, rigidity modulus, and bulk modulus. Let us see the first modulus, Young's modulus. It is implied by the letter E. It is defined as the ratio of longitudinal stress to longitudinal strain. See the diagram. It is the rod of length L and area of cross section A. Here the tensile force F is applied. The rod gets elongated. So the longitudinal stress equal to F by A and the longitudinal strain, which is equal to L by L. That is change in the length by original length. Hence, Young's modulus E equal to F into L divided by A into L. Note down this formula, it's a very important one. Problem will be asked in this topic. Now let us see the second one, rigidity modulus. Already we have seen all the terms and pictures in shearing stress and shearing strain. Hence, rigidity modulus G equal to tangential stress divided by shearing strain, which is equal to F divided by A divided by phi, the angle of shear. Take a small hint of all the formulae. It helps in the revision time. Third one, bulk modulus. It is implied by the letter K. K equal to F divided by A divided by change in volume divided by original volume. Small v divided by capital V. Next, let us see Poisson's ratio. It is implied by the letter nu. Poisson's ratio is defined as the ratio of lateral strain to longitudinal strain. Now see the diagram. The force is applied along the lengthwise, so length gets elongated and its radius gets contracted. L is the length of the rod and delta L is the change in length or elongated length. R is the original radius and delta R is the change in radius. Hence, Poisson's ratio nu equal to minus delta R divided by R divided by delta L divided by L. It is a dimensionless quantity. Theoretically, the limits of Poisson ratio is between minus 1 and 0.5. But in actual practice, Poisson's ratio is a positive quantity. So its value lies between 0 and 0.5. Next, let us see some relations. First one, relation between angle of shear and linear strain. Linear strain is nothing but tensile strain is implied by the letter small e, and angle of shear is also known as shearing strain. It is implied by the letter phi. Hence, phi equal to 2e, or we can say E equal to phi by 2, which may be a tensile strain or a compressive strain. Next is the relation between volume strain and linear strain. Volume strain which is equal to 3e. Next is the important topic, relation between three elastic moduli. And now recall the letters E, Young's modulus, G, rigidity modulus, K, bulk modulus, lambda, extension per unit stress, mu, contraction per unit length per unit stress. Here I have given the important equations because derivation is no need for the exam point of view. Lambda equal to 1 divided by E, 2 into lambda plus mu equal to 1 divided by G, 3 into lambda minus 2 mu equal to 1 divided by K. The very important formula, the relation between the three moduli E, G and K is E equal to 9GK divided by 3K plus G. Note down this formula, it is a very important one. Next, let us see the relation between G, K and nu. Nu equal to mu by lambda. Hence, nu equal to 3K minus 2G divided by 6K plus 2G. Next is the relation between E, G and nu. Nu equal to E divided by 2G minus 1. Now let us see the last topic, work done in stretching a wire. Work done W equal to half into stretching force into elongation produced, which is equal to half into stress into strain. The work done in stretching a wire is equal to the potential energy stored in the wire. Thank you.